Sutton here, bringing you the IM363 Extra Practice number 4 solutions on adding and subtracting rational expressions. Let's go ahead and check out the puzzle that goes with this extra practice. Alrighty, so here's our puzzle for this one. We're trying to solve the riddle, why do helicopters get sick so often? The idea with this one is we have these 9 rational expressions that we have to combine and simplify and match with one of these answers down below here. Now, once we've matched it, whatever letters are next to the answer, we'll put next to the appropriate numbers down in these boxes below. For example, if I solve number 1, or simplify it, and for some reason I come up with, I don't know, this NTT option here, then I would put NTT in the ones here. Now, I don't know that that's actually the answer, but that's just how it works. So let's give it a shot. So here we go with our first problem, 7 over x minus 3 plus 4 over x squared minus 9. And you'll notice that I've split up my answer choices to have some above here and down here, just because then I can actually fit some work for doing these problems in between. Now, also a strategy I'm going to use on this, in the very beginning I'm always going to factor as much as I can, at least for the denominators, to help me find the least common denominator. So on this problem, I noticed that this x squared minus 9 can be broken down a little bit. We have different denominators in any case, so I can't just add these together the way they are. So my first fraction I'm going to leave alone for the time being, but this next one I can split up x squared plus 9 using my square root plus minus shortcut. So I'll have square root of x squared, which is x, plus the square root of 9, so 3, and then x minus 3. Now, looking at these different denominators, I see that this denominator here, I always look at the bigger one first. This one has an x plus 3 and an x minus 3, so both of those have to be included in my LCD. And then looking at the other denominators, we have an x minus 3 over here. Since I've already got one x minus 3 in this first denominator, and I've already included that in my LCD, I don't need another one. So I'm just going to move on to the task of getting this first fraction to match the denominator for the second fraction. So to do that, a trick I'm going to use is I'm basically going to divide the LCD by whatever's in the denominator, and whatever I get when I do that division, that's what I need to multiply that fraction by. So dividing this all by x minus 3, that would leave me with the x plus 3. So then I have to do 7 over x minus 3 times x plus 3 over x plus 3. I have to multiply by an expression over itself so that I'm really multiplying by 1, which does not actually change the value. My second fraction, I'm just going to leave the way it is. It already has the LCD. So going back to my first fraction now and distributing that out, and you'll notice I included these parentheses here even though I don't technically need to, just to make sure I distribute. So I'm going to have 7x, and then 7 times 3 gives me a plus 21 up there. And I should have x plus 3, x minus 3 down below. That was kind of the whole point of this, is to get that LCD down there. And then my second fraction, again, I'm going to keep that the same. Now that I have the same denominator, let me add my numerators. So denominator is going to be x plus 3, x minus 3. And upstairs I have a 7x. That's not getting combined with anything. 21 plus 4, though, is going to give me 25. Can I factor 7x plus 25? I always have to look to see if I can break it down and reduce further. There are no common factors for 7x and 25. This is as good as it gets. So let me find this answer choice down below or above. I see actually DCA has everything I need here. So that's what I'm putting in spot 1, D, C, and A. And it's on to the next. Next up, we've got problem number 2. Just like before, let me see if I can factor out my denominators to help me with the LCD finding process. First fraction is good the way it is so far. Second fraction, though, denominator there, I can take an x out of x squared and 5x. So if I do that, I end up with x and x plus 5, or x and just plus 5, I should say. Now looking at my denominators, I'll do my larger one first. So this one has an x and an x plus 5. And the other denominator just has an x plus 5. That's already covered by the x plus 5 I included there. So let me just go on and see if I can get the same denominator. So the first fraction, in order to get an x parentheses x plus 5 there, I need to multiply by x over x. And then the second fraction is fine the way it is. So back to the first fraction, Numerator, we're going to have x squared, x times x. Denominator is going to be x parentheses x plus 5, and I'm not going to bother distributing ever in my denominator because there's a chance that when I put stuff together in the numerator, I'll be able to factor and cancel. I don't want to have to refactor the denominator by distributing too soon. So we've got our second fraction staying the same. Combining it all now, we have a denominator of x parentheses x plus 5, and then we have x squared plus 7x plus 10, so just add all that together. Now in my numerator, I think I can factor this a little further. Things that multiply to 10 and add up to 7. Let me see. 1 and 10 doesn't work. 2 and 5 does. X plus 2, x plus 5 in that numerator now. And lo and behold, these x plus 5s actually can cancel out. So that leaves me with x plus 2 over x. And x plus 2 over x, I see that, let's see, where is that? Right up here, that's the. So that goes in spot 2 right here, T-H-E. That might be actually the word the, or it might just be the first 3 letters of some other word. We don't know until we figure out what those 4s are. So let's keep going. On this problem here, I see in my denominator for the first fraction, I can take an x out of both of those. So if I take out that x, I have an x minus 4. Next fraction is already as factors as it's going to get. So now for my LCD, my larger denominator has an x and an x minus 4 in it. And the other denominator just has x minus 4, so that's already covered by this LCD. So multiplying out by those fancy forms of 1. First fraction is good the way it is. Second fraction, to get the LCD, I just have to multiply by x over x. So continuing here, first fraction I'll bring down just one more time, and the other fraction I'm going to have x squared over x parentheses x minus 4. Combining the numerator now, in addition to the x in parentheses x minus 4, I have an x squared, a plus x, and a minus 20 up there. Now let's see if we can factor this. Things that multiply to negative 20 and add up to 1. Not 1 and 20, 2 and 10 doesn't work. 4 and 5 works, negative 4, positive 5. So I can write the same denominator, and also I'm going to have x minus 4, x plus 5. X minus 4s can cancel. So that leaves us with x plus 5 over x. I see that right up here, that's EST. So let's put that in spot number 3 toward the end over here. EST. On this next one, it looks like I can factor my second denominator. So let's keep the m plus 5 there, that's fine. But now m squared minus 25, I can use my square root shortcut, plus or minus. So that'll be m plus 5 and m minus 5. So m plus 5, m minus 5, that's got to be in my LCD. And then this m plus 5 is already covered by what I wrote there. But I can multiply that first fraction by m minus 5 over itself to get this whole LCD there. Second fraction I'll leave the same for now. Simplifying my first fraction, distributing, I've got m squared minus 5m all over the LCD, m plus 5, m minus 5. Second fraction, let's keep that the same for one more step. Now combining these together, I'm going to have my common denominator of m plus 5 and m minus 5. And in the numerator, I'm going to have an m squared and let's see, minus 5m plus 10m, that's plus 5m. Now I can factor out my numerator. Take out an m from that, we've got m plus 5. M plus 5s cancel, so that's m over m minus 5. And I see that down here, WHI, so that's going in spot number 4, WHI. Here we go with another one. As always, I'm going to try to factor in the beginning to see if I can find an LCD. So my m plus 3 is as good as it gets for that first fraction. For the next one, though, we can split this up here. So things that go into 15 and add up to 8. That would be 1 and 15 doesn't work, 3 and 5 works. So we have m plus 3, m plus 5. And now I see for my LCD, I at least need the m plus 3 and m plus 5. And looking at my other fraction, the m plus 3 is already covered, so I can start getting a common denominator now. For the first fraction, this has everything except for the m plus 5. So let me multiply by m plus 5 over itself. And then this second fraction is fine the way it is. Back to the first fraction, let's distribute that now. So 2m plus 2 times 5 is 10. And then we have m plus 3, m plus 5 down there. Second fraction, let's just keep that the way it is for now. And now adding these together, I have my common denominator of m plus 3, m plus 5. 2m doesn't get combined with anything, but 10 plus 9 can get combined. That's 19, so 2m plus 19. Taking a quick look just to be sure, there's no common factors I can pull out of 2m or 19, so I'm just going to leave that the way it is then. And that is going to be, let's see where I can find that, right here, ERM. So the ERM then is going in spot number 5, ERM. On this problem, let me go ahead and start factoring so I can figure out my LCD. First fraction can be factored a little in that denominator. So I'm looking for factors of negative 28 that add up to 3. 1 and 28 doesn't work. 2 and 14 is no good. 4 and 7 works if I have negative 4 and positive 7. So we have 11m and then m plus or minus 4 and m plus 7. There we go. And then that second fraction is fine the way it is. So for my LCD, definitely have an m minus 4 and an m plus 7. And looking at my second fraction, the m plus 7 already is there, so we're good to go. So my first fraction is fine the way it is. We already have the LCD there. For the second fraction, we're missing that m minus 4. So let me multiply by m minus 4 over itself. Continuing on, let me keep that first fraction the way it is for now. And then this other one, I'm going to distribute the m in the numerator. So we have m squared minus 4m all over my LCD of m minus 4, m plus 7. Let's combine these like terms in the numerator. Denominator is going to stay the same, m minus 4, m plus 7. Now in the numerator, we have an m squared, and we also have 11 plus negative 4 gives us a 7m. So m squared plus 7m. Taking a quick look, it looks like I can factor out an m from all that stuff up there. So denominator is the same for now. Take out an m. We have an m plus 7 left over. Let me cancel the m plus 7s. So then that's going to be m over m minus 4. And let's see if I can find that. That's up here. That's BIR. So that's going under spot 6 right here. BIR. And that looks like the word bird, but let's see if that's really everything we're looking at when all is said and done. On to the next. All right, things are about to get switched up a little bit with question 7. So let's start with the good news. Looking at my denominators, there's no way to factor those any further. What you see is what you get. So coming up with the LCD then is pretty easy. We just go through and pick something from every denominator. So we have an a plus 2. We also have an a minus 5. And that covers everything in both denominators. Now here's the bad news. Neither of these fractions already has the LCD. So that means each one of these has to get multiplied by something to give it this complete LCD. The first fraction is missing the a minus 5. So we'll do 3 over a plus 2 times a minus 5 over itself. The second fraction is missing the a plus 2. So we'll do 8 over a minus 5 times a plus 2 over itself. And let's go ahead and simplify this a little bit before I try to combine anything. So for my first fraction, distributing that 3, we've got 3a minus 15 all over the LCD, a plus 2, a minus 5. Second fraction, 8a plus 8 times 2 gives us 16. And again, the LCD gets carried over there. That was the whole idea of what we multiplied by. So let's combine stuff now since we have the same denominator. So keeping my LCD the same, we've got 3a plus 8a is 11a, and then negative 15 plus 16 is going to be positive 1. 11 and 1, there's no common factors I can pull out of there, so this is already as factors as it's going to get. No common factors to cancel out. So let me go ahead and find this in the answers. And I think I see it over here, 11a plus 1, all over that stuff. TCH, that's going in spot 7. TCH. We're getting there. 2 questions left. All right, so question number 8, they must have been saying, all right, no more Mr. Nice problem math writer person. We've got 3 terms instead of just 2, so that complicates things a bit. Let me start by factoring whatever's not already fully factored. This first denominator is actually the only one that we need to spruce up a bit. We've got perfect square minus another perfect square, so that's going to be a plus the square root of 4, so a plus 2, and a minus 2. Now, before I go ahead and just rewrite the other fractions, I'm going to be taking up a lot of room with this question. So I think I can actually determine right now, before I keep writing anything, what my LCD is going to be. So we have an a plus 2, a minus 2. That's at bare minimum what we need in the LCD. And looking at my other fractions, the a plus 2 here is already covered by this LCD, and the a minus 2 in my third fraction is also already included here. So I've already got the LCD then, if I just look at this one. Now I'm going to go ahead and directly start multiplying these other fractions by what they need to get this LCD. Normally I would just rewrite stuff and do that on a separate step, but again, I need to save some space. So my second fraction is missing the a minus 2 part of this. So I'll do 2 over a plus 2 times a minus 2 over itself. The third fraction is missing the a plus 2 in the denominator. So I'll do 5 over a minus 2 times a plus 2 over itself. Let me go ahead and simplify all this now. So we have our first fraction. I'm not going to change that at all yet. Next fraction, distributing that 2, we've got a 2a minus 4 all over the LCD, a plus 2, a minus 2. Third fraction, we have 5a plus 10 all over the LCD. And at this point, it's time to combine like terms. So we've got an a plus 2, a minus 2 downstairs, and upstairs, let's see what we have. I'll do the a's first. So we have a 2a plus a 5a. That's a total of 7a. Now for the constants, we have a 6 plus negative 4 is 2. 2 plus 10 gives us 12. 7a and 12 have no common factors that I can pull out, so that's as good as it gets there. So that means that I just have to look for this answer. 7a plus 12, let's see if I can even find that. That is, where is it? 7a plus 12, right there, right down there. And then I have the same denominator, so I have an RLY going in the 8 boxes. So RLY. And then that's it. On to the last problem. So here we go with our final boss battle for this one. So we've got, again, 3 terms, which is not ideal. I did things a little differently this time around. So I'm going to factor just like I always do in the beginning. But when I factor this middle term, because this is the only denominator that needs to be factored, I'm actually going to write this fraction first and then write the other one after I figure out what they're going to need to get the LCD. So we've got 7 over something. So things that multiply to negative 12 and add up to 1. 1 and 12 doesn't work. 2 and 6 doesn't work. 3 and 4 works if I have negative 3 and positive 4. So a minus 3, a plus 4. And now for the LCD, I have to have the a minus 3 and a plus 4 in there for sure. Looking at my other fractions, the a minus 3 here, already covered by the LCD. The a plus 4, already covered. So now I just need to turn these other 2 fractions into things that have this whole LCD. My first fraction, with the a minus 3, it's missing the a plus 4. So I need to multiply that first fraction by a plus 4 over itself. And now my last fraction, 1 over a plus 4, that needs an a minus 3 for the LCD. So we'll multiply this by a minus 3 over itself. All right, let's go ahead and simplify this a bit. First fraction can stay the way it is. The next one, I'm going to distribute that 2. So that's 2a plus 8 all over the LCD there, a minus 3a plus 4. Last fraction, I'm just distributing a 1, so that's kind of silly, but that's just going to be a minus 3 over a plus 4a minus 3. Now it's time to go ahead and combine all of these together, the numerators. So for the denominator, it's just the LCD I've been writing all along. Now for the numerator, we have a 2a plus an a gives us a 3a, and then 7 plus 8 is 15, minus 3 is going to be 12. Now 3a plus 12, I can factor a 3 out of all that. So that leaves me with a plus 4, which conveniently cancels out the a plus 4 down here. So I'm left with a final answer then of 3 over a minus 3. And we know we can't cancel those 3's out. So that's going to be HEG up here. So let's put that in spot 9, HEG. All right, so we got all these letters filled in. We're finally ready to solve the riddle of why do helicopters get sick so often. So we have THE, pretty sure that's the, and then we have whirly, maybe whirly, and then bird. A whirly bird, I think, is another term for a helicopter, so that kind of makes sense. And then we have cat, chest, no, cat, that doesn't make sense. Catches, and then that T is part of another word. So the whirly bird catches the germ. The whirly bird catches the germ, like the early bird catches the worm, but with a helicopter and a germ that I don't know how the helicopter actually gets sick. Anyway, till next time, Mr. Sutton signing off.